So in the last video, we talked about how to train the machine learning models. And here we're going to do a very, very short overview of how to actually evaluate them. And the reason it's going to be short is there are a lot of resources out there about model evaluation. And if you want to jump into them, I give you some of those links, but also you don't necessarily need a deep dive for this class. You need to understand the beginnings of the model evaluation, and then the deep dive can be very specific to what it is you're trying to do with machine learning. So the question you need to know is, that you need to answer when you're training your machine learning is, how do you know when your machine learning has performed well? You have to define what well means. So the user needs to define a performance metric, and this performance metric is very specific to the problem. I find that students often want to use accuracy, probably because this is what you've grown up with on exams. You basically get an accuracy answer on your exam, number of right answers divided by the number of examples or number of questions. Accuracy is an okay metric for some things, but it's not a great answer for skewed data. Let me give you an example. I can be a fabulous tornado forecaster if I am forecasting tornadoes and being measured by accuracy, because most of the time there's not a tornado. So all I need to do is say no. By my accuracy, I'm probably 99.99% accurate. So all of you would say that's a great model. And yet it's terrible, because when you actually need it to tell you that there's a tornado out there, it's not telling you that. So it's not the best metric. So what we're going to talk about briefly is a couple of metrics that basically mostly come from this contingency table that is built. So basically, this is for binary problems only, where you are saying yes or no, and then you create a table that is the observations of whether or not the event happened, and then whether or not you forecast it to happen. And then you can have, if you forecast it to happen and it happened, it's called a hit. If you forecast that it didn't happen and it didn't happen, it's called a correct negative. And then the other two entries are the ones that you really want to make sure that you don't have. If you forecast it to happen and it didn't happen, it's a false alarm. And if you didn't forecast it to happen, but it did happen, it's a miss. And if you go to our tornado example, those two categories are bad. You don't want to be blowing an alarm all the time, and you don't want to miss the tornadoes that actually matter. You want to have the mass of your table along the main diagonal, the hits and the correct negatives. And you can do this as multiple categories. For now, we're just going to stick with two. This table comes from a web page that I have linked in your main web page for this module, and I want you to look at the web page because it has a lot of different verification metrics in it. So that is a fabulous reference for verification. And the ones I want you to go look at, rather than just explaining them all in a video, are accuracy, which you probably know a lot about, probability of detection, false alarm rate, and bias. These are all ones that might be useful to you throughout your machine learning in this class. I want to, before we jump to that, say that what we just talked about is for classification. If we're doing real valued verification, we also need to be looking at different metrics. And for example, accuracy isn't going to do anything there. Your typical metrics in real value verification are mean squared error, root mean squared error. So those pretty much mean exactly what they are. They are the error squared up and then averaged, or averaged and then square rooted because you're doing a square. And also absolute error. And all of these are given with formulas and more explanation in that web page that I link to. So I will see you in the next video.